And it's the moment you've all been waiting for. Part 3 of our 3-part series of the Saga of SohCahToa. Sorry guys, this is weird to be dramatic without you here. But anyway, when we met last time, we had SohCahToa, who was in a mind-blown situation. She had just discovered that some triangle measures can result in 2 solutions, or sometimes even no solution. It was all very ambiguous, and she was on her way to really regretting her decision to knock that wall down. She, for the first time in her adventure, started wondering what happened to Pythagoras, and she really started to miss him. Now you remember Pythagoras is out cold in his right triangle house, twitching thumb on that remote and everything. But he has finally started to awaken, and as he does, he looks around him and he's very, very confused because all he can see is a triangle, but he can make no sense of it. Pythagoras only lives in right triangles, and this triangle has no right angles. He's just trapped and feeling very anxious and wondering where SohCahToa is to boot. So in order to kind of alleviate his mind and relieve the stress he's under, plus the splitting headache he has, he starts to think about that right angle that he has lost. There used to be a wall here, wasn't there? I was leaning against it. So he quickly takes a bunch of measurements and he measures, let's relabel our house here. So remember, I think I had these labeled as angle A, B, and C. And across from A is side A, and side C would be here, and here's side B. And he's all good with that. But where is this wall? He can imagine it, but it's not there. So he kind of sketches out on a napkin what he would have had if it were there. And if it were there, he knew that H was the height. And this distance right here, he really has no idea what that is. So he does what a lot of mathematicians do, and he just puts an unknown X on that. And then he just kind of does what Pythagoras does. He just writes that x squared plus h squared would equal that hypotenuse length a squared. And that's all good. And then he's on this napkin and he's like, well, what about this right triangle? And then this right triangle, he also doesn't know what this side is. But rather than call it like y or something, he's going to just recognize that the whole length is b. And if he takes out this part, he'll have the whole b minus the x that he doesn't want. And then his Pythagorean theorem comes back. So b minus x, that side squared, plus h squared equals c squared. And he's got these 2 equations and he's thinking, I bet if I could solve these equations, if I could just get rid of that x in those equations, then I could know a little bit more about this triangle I'm living in. So he does just that. Noticing that there's an h squared in both of these, he decides to solve for h squared. Over here, that looks like h squared alone would be c squared minus the b minus x squared term. And over here, h squared by itself is going to be a squared minus x squared. Since h squared is equal to each of these, he just brings these 2 equations into one equation, where c squared minus b minus x quantity squared is equivalent to a squared minus x squared, since after all, they're both equivalent to h squared. Then using the algebra he picked up along his math journeys, he decides to expand the b minus x quantity squared, and that becomes b squared, 2 bx terms, negative, and an x squared term. And bringing the rest down and subtracting all of that and distributing that negativity through there, he is grumpy today, he gets negative b squared plus 2bx minus x squared. And this is still equivalent to this side, a squared minus x squared. And then he sees what he can do. He is getting rid of those x squareds. By adding x squared to both sides, they are gone. Bye-bye. So he is feeling pretty good. Now he's got c squared minus b squared plus 2bx. Oh, he thought he got rid of that x. Equals a squared. Oh man, Pythagoras is not feeling very happy. He is tired. He has a headache. And now he still can't get rid of that x squared. How in the world can he get rid of the x squared? Dun, 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 dun! SohCahToa comes flying in from nowhere. Yeah, I said flying. Here she is. Superwoman cape, arms straight out, flying in from nowhere and says, I know how to find x. X is all about this triangle that you drew this picture of, Pythagoras. X in this triangle depends on this angle C right here. The cosine of angle C is equal to x, the adjacent, over A, the hypotenuse. So x by itself would equal A times the cosine of C. Dun, 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 dun. And bringing that down in here, we have C squared minus B squared plus 2B, throw out the x, make it A cosine of C equals A squared. And now we have a formula that has no unknowns. Only the sides and angles of the triangle are what we need. And Pythagoras is dumbfounded. And SohCahToa is dumbfounded also because, let's just look at it. If we solve for C, we get C squared alone. B squared is going to come over to the other side. A squared's already there. It'll be a positive B squared. This whole term is going to come over in a subtraction. Flip-flop the A and the B, cosine of C. And there you have it, ladies and gentlemen. We have the Pythagorean theorem. Can't spell it. And we have some SohCahToa. All in the same formula. Reunited and it feels so good. Reunited and we understood. There's one perfect fit and sugar, this one is it. We both are so excited 'cause we're reunited, hey, hey. That was just a little song for you. That is the end of the Saga of SohCahToa. They are back together in this formula right here, which we call the law of cosines. And we're going to use this to solve more problems of unknown triangles. So the law of cosines is, let me just talk to you about the law for a minute. We've got C squared equals A squared plus B squared minus 2AB cosine of C. That's angle C. So something to notice is that side C and angle C are both in the problem, and they are named the same because they are, like we've seen before, they're opposites in the triangle. Okay, so the biggest question that comes up is, how do you know which side goes here? Because A and B are also sides, and which angle you use, and all those questions. So the nice thing is it doesn't really matter. If you want to find, for example, if you want to find like side A, you put side A all alone, all by itself on one side of the equation, and you use the other two sides, which will be B and C. Those are going to be squared and added, minus, it'll be 2BC, and the cosine of angle A. So it doesn't really matter how you spell them, but these two parts need to be opposite parts in your triangle. So let's do an example, and you'll need your calculator. So get your calculator and make sure it's in degree mode because we'll be working in degrees. And I'm not sure where my calculator is. I'm going to pause this video. You pause it too if you need to go get it, and we'll be back. Okay, I found my calculator. Let's get on to a problem. So let's sketch ourselves a triangle. And let's give you a few given pieces of information. So in this formula, it's important that we have two side lengths that we know. So let's just make up some numbers. Let's say this side is 21, and this side here can be 37. So you need the two sides, and then you'll also need an angle between those two sides. So where those two sides come together, you're going to need that angle. Let's say this is a 53-degree angle. So if you remember in geometry, when you have two sides that you know and the angle that's between them, that's what we call the side angle side pattern. And that's when you're going to use the law of sines, and you'll use it to find the side across from the angle that you have. Okay, just as the formula says, you're going to put the side that's opposite the angle you have. So the side goes here and the angle goes here. The other two sides are used in the equation as well. So this one will look like this. The side x squared by itself is equal to the other two sides, and the order here doesn't matter, so let me just use 21 first. 21 squared plus the other side squared, which would be 37, square that, minus 2 times the same 21 and the same 37 times the cosine of the angle that they form, which is the 53-degree angle. And again, that's opposite of the x. So these two are always opposite each other. All right, the rest is really plug all that into your calculator. And so in the calculator, I am going to enter all of it together. Let me check and make sure I'm in degree mode, and I'm not. Good thing I checked. Okay, so here I'm in degree mode. Then I'm just going to go 21 squared plus 37 squared minus 21 times 37 times the cosine. Oh, wait, back it up, back it up. I forgot something. Do you see what? I forgot the 2, so I'm going to actually delete this. So I'm on the minus. So minus 2 times 21 times 37 times the cosine of 53. I'll close that parenthesis. All right, so that's the entry. So it's 874 and some change there. Now, you got one more step to do. That's not your answer. That is, and I'm not going to round this, dot, 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 that. That's what x squared equals. So you know how to get x. We're going to take the square root of that value, which I'll just do straight in the calculator. So taking the square root of that answer, this is my answer. So it's rounded to the nearest thousandth, 29.577. Okay, that's my x value. Then, of course, if I had units, I'd put units on it. Check for opposite part relationships. Is the biggest side across from the biggest angle, all that good stuff. And that's using the law of cosines to find a side. Now, you can also use the law of cosines to find an angle, but you're going to want to do a little bit different work with the formula. So let's look at how to use the law of cosines to find an angle. All right, so when you have the law of cosines, you're looking for a missing angle. You want to revise your formula a little, and you don't do this every time. You just do it one time and then use the formula in a new form. So let's see how that formula can be revised. Using c squared equals a squared plus b squared, Pythagorean theorem, minus 2ab cosine of angle c for our law of cosines. What we're going to do here is just solve for the cosine of angle c. We want to get that by itself. Okay, so to start off, let's move the whole term to the other side of the equal sign, which will be positive when we move it to the left. That'll leave a squared plus b squared, and c squared on the left here is going to come over to the right side as a negative c squared. Okay, then one last step to get cosine of c alone. If I want cosine of c alone, I will, back up here, I'll just divide off the 2ab factors that are on both sides, or do that on both sides. So cosine of c alone is a squared plus b squared minus c squared all over 2ab. Okay, so as a formula, we'll use this for finding a missing angle. Okay, now what will you have to know? What will be given to you? Well, you'll need the A and the B and the C. So that boils down to knowing all three sides. So you know side, side, and side. And you're looking for an angle. This is when you use this law. So let's do a quick example of that. Let's say you have a triangle, and you know that this side is 14, over here is 23, and this is 24. And you'd like to find one of the angles. You actually could find any of the angles with this, but let's say you want to find this angle right up here. So let's call this theta, and that's what you're looking for. So the thing to do with this formula is notice again that the angle in the problem, which is angle C here, doesn't have to be named angle C, but it's the angle in the problem, has a side across from it that's found in the formula right here. And notice that's the one in the numerator that's being subtracted at the end. Okay, the others are being added and even divided on the bottom, but the one that's by itself being subtracted is the side across from the angle that you're using there. So if I want to find angle theta, I need to make sure that I use the 24 in this subtracted spot. The other two sides can be interchanged. So it'll be the cosine of theta. It'll be 14 squared plus 23 squared, and then minus. Here's the one that matters the most. 24 squared is the one we're subtracting. And that's divided by 2 times 14 times 23 in the formula. So that opposite part relationship is still holding. This angle and this side that you're subtracting are opposite each other in your diagram. Okay, now as far as calculating this, you're going to want to do this also in the calculator. And there's a really nice template that I want you to know about if you don't already. It's to build good fractions, and it's in your calculator as a template under F1. So look at this very first button, that green F1. There's a menu in there. You access it by hitting alpha first. So I'm going to go alpha F1, and it's a fraction template. And the first one will give you simply numerator over denominator. If you select that, notice you just get a couple of boxes that you get to basically use to fill in the blank and build your fraction. That'll help you avoid errors in entry. Okay, so I'm going to enter my fraction as 14 squared plus 23 squared minus 24 squared, and then divide all that in the denominator by 2 times 14 times 23. Can you see it? I hope that's not too blurry. Okay, entering that, and I get a fraction. So I'm kind of a little surprised. Usually I end up with decimals on that, but I'm not worried about the fraction. I just know that the cosine of the angle theta is the fraction ratio 149 over 644. Clearly that is not our angle. So back to how do we find the angle then? Well, we're going to have to do our inverse cosine operation. So our angle is the inverse cosine of that ratio 149 to 644. Okay, not too hard. We'll just inverse cosine that number. And we get our angle. So it's 76 and some change degrees. 76.622 degrees if I'm going to go to the third decimal place. All right, now if we were in class together, I would encourage you to find another angle in there. So I want you to pause the video and see if you can use the law of cosines to find, let's call this angle right here alpha. Okay, I want you to use the law of cosines, use this example we just did, to find angle alpha. Pause the video and I'll be back with the answer so you can check yourself. All right, I hope you did well. Let's check your work here. So here is my approach. I have my law of cosines. I've got alpha, and opposite alpha in the diagram is the 14 side. So that's the one I'm subtracting in the fraction. The 24 and 23 are also here being added, but the order doesn't matter on those. So you can switch those around if you need to. My ratio ends up being 303 over 368. Maybe you got a decimal form of that. That's not a problem. As long as when you inverse cosine it, you get this angle 34.576 degrees was the answer. So here's the work in the calculator. Probably kind of blurry. Apologize for that. So check yourself on it. All right, so that's the law of cosines. You can use it to find an angle or to find a side. Just depends on if you're given. The thing to look for is your givens. If you are given two sides and the angle that's between them, or if you're given the three sides, and use the two different forms. Okay, so good luck with trying these out. I know you can do it.